Hi everyone, Masoudi here.
Hi guys, this is Dimo from Masoudi.
Last session we showed you an example of how two applications, how two processes can connect to each other with the aid of IPC, inter-process communication. We talked a lot about that, and we showed you some example. We wrote this server socket that was listening on port 1, 2, 3, 4, 5, and we copied and pasted this part to the client socket test, the same code, and it was connecting to the server side. They were sending, it was like a simple chat application, if you remember. For example, if you wrote something here in this side, in this endpoint, it was sent to the other side, printed there, and vice versa. And as this is the only way of communication between two processes, and because we are going to separate, extract another application, a customer application, a standalone customer application that will be running on the machine of the customer, for example, on the customer mobile device or customer's tablet or desktop machine, a PC or something like that, because that process will be running on the other machine, maybe far away. And so we were looking for a mechanism to connect the customer application to ours and make, a way to connect both to each other. So we chose the socket programming, and the socket programming is the only IPC methodology for two processes connecting to each other that are even from different operating systems that are even far away from each other. And the socket programming has some API, has an API in every programming language. Maybe sometime I show you, for example, connecting this Java Kotlin application to a Python socket. And you'll see that, maybe we'll do that later as a fun project, side project. Now we are going to continue. We are going to use this mechanism, and we are going to continue the application, our application that we were working on, and it has been left. Some features are uncompleted. For example, we were working on this product repository. I remember most of the things are to do. We've not done it yet, and and also, for example, this modify customer is empty, or modify product, nothing is being done here yet. But let's switch the gears a bit, as I said before. Let's move toward writing a customer application that is connecting to this admin application. For example, the admin of the shop, if the admin of the shop didn't have any kind of application for managing his or her business, then the manager would do all these things manually with the phone. For example, the customer either should come physically to the shop to grab the things and buy them, purchase them, or in order to order from far away of the shop, the customer has to call through, for example, phone, and the manager should be, should hire someone that is answering the phones and writing down the orders of the customers. That is pretty much, the standard, default way of managing a small shop business without any application, without any program or something like that. But we are going to automate this process, the whole process. And in this part, we are going to work on the bit of connecting the customer to this admin. So the customers will send orders, will place orders from their own application far away from the shop. And the shop manager will see all the orders and, for example, will fulfill them, will grab a basket or create shopping cart for them, and will, for example, announce the customer that is coming, it's on its way, or something like that. It will grow, this application will grow a lot, So for connecting two applications here, we are going to use this, we have no other choice other than using the sockets. We are going to connect these two applications via the sockets. The customer will connect to our application, will of course ask for the list of products and their prices. After taking back the products and the prices, Then, for example, the customer will decide, okay, I want, for example, this much of this product, this much of this product, for example, 5 apples, 3 oranges, 2 kilograms of, for example, I don't know, potatoes, and then will send the order to the shop, and for example, will send his address, phone, his name, his or her name, and yes. But for this is the first step that we are going to take in writing the customer application. So this main here, this main that we have here, has this main function, which is an entry point of the application. When this runs, we have a while true that showing the main menu over and over, and the manager is selecting, for example, one of these features and is working with this application. But we need another main for entry here, and for the moment we are going to write the customer application in the same project and as a Kotlin application, just for the moment. The customer application will be a console application as well. First, just we want to have 2 processes running separated, standalone, far away from each other, and after that, then we will turn this console application to some UI, GUI, graphic user interface applications. For example, maybe we'll use Android or Flutter or the Compose API that is very recently new. Yes. But first, we are going to, like this one, we're going to write a console application, and we will be working on the connecting part, connecting these 2 applications, the customer and the admin. So the first part, let's create another file. I'm going to create another Kotlin file, and I'm going to name it customer application. And let's rename this one, the main, to
admin.
Yes, admin application. And so we have the customer application, the admin application. Let's have a main entry point for the customer application as well. And now, for example, if we have a print ln here, just to say hi customer and run it, just to show you that, okay, it's running. And also the main side, the admin application, this is no more main, this is application, admin application from this point on. And the admin application, yes, connection refused because it was running the, it was running the previous session's example. Yes, the socket one. This is the one, let me run it again. Yes, now it is running the customer application, KD, hi customer. Okay, so the admin application is working. Let me run that for you again. This is the admin application. It has a menu. The admin can enter anything, for example, 5, 6 for printing the product list. And yes, the operation is not implemented. This is because the product repository, we have a lot of not implemented here, as you can see. The save and fetch all. We were working on this. We will return to this for working with that. And just I want to show you that now we have 2 applications, and when we run them even from the same project simultaneously, we will have 2 processes, standalone processes that has nothing to do with each other. They are from the same code base, of course. They will have the same code. They will have the same files here that we have, everything. But, I don't want you to be confused that, okay, there are not 2 processes. Actually, they are running from the same code base. Running from the same code base doesn't mean that they are the same process. When we run this main once, and when we run the other main in the other file, we have 2 processes. I'll show you that in the process monitor manager. This is a Linux machine. I'll show you that. So, okay. Now, this main application here, this is the admin application. This should be listening always to all of the orders. Mm-hmm. And at the same time, this admin also should fulfill the needs of the physically, the customers that are in the location in place.
Process them.
Yeah, should also work with the application to fulfill their needs. For example, a customer has come physically asking for something, and at the same time, some customer far away is calling, is calling the phone, or maybe is placing an order through the customer application, which we are working on here. So, but here we have only just one thread. You know, when we run this main, I don't want to talk about threads here a lot. Maybe I'll talk about them later in great detail. But just suffice it to say that when we call this main function here, we are creating a thread, and the main thread that will start from this first line here, 270. It will come to this line, it will run here. Then from here, the thread will go here, will run all these, then will return back again to the main here. Then it will loop, then it will go, and you get the idea here. We have a thread that is following all the instructions step by step, one by one. But we want to also have another thread, another entity, another being that is listening, just only listening to the orders, just for that purpose, you know, side by side by this main thread. So we should create another thread for that. So creating thread in the Kotlin, I'm just going to use the API of creating the thread of the JDK, but it's not the best way actually in the Kotlin, the recommended way of doing you know, concurrent stuff, concurrency. This is the concurrency issues, concurrency processes, concurrency tasks. Creating a thread, a new thread for every concurrent task is not a good idea, but just for is the least, you know, is the last option that we should take. But here, because it's the easiest one, I just want to go with that option. Later we can come to better solutions for concurrencies and parallelism, like for example, all RX libraries or the coroutines in the Kotlin, which is very, you know, high tech. I can say it is perfect. But just for the moment, for creating, you know, so when this process starts, each process starts with only a single thread, running the applications from the first line of that thread, going forward to the last line. Or if we have some kind of loop, it will just loop there. Then, if we want to that process have, for example, 2, 3, 4, 5, as many as we need, standalone threads that are, you know, separated, you know, from each other, each of them just following their own lines and executing their instructions in the way, in the path, we have to put, for example, I put this into this thread. I put this into thread. Now just look what happens if I run this. I put it into this thread. The application just starts and let me see. It's not stopping. I just actually expecting it to exactly stop after that, because this thread is creating a new thread and then running this while loop into other thread. But the main thread, after executing this part, will just exit. And when the main function when the main thread exit and reaches its last line, the whole application will exit. But here I think they have done something that while there is at least one active thread, they are not maybe closing the application, exiting the application.
That was the previous.
Yes, that's the thing. So here we have created this thread just listening for this console here, for the, you know, entering one of these features, just sitting there waiting for the admin to call them. And I create another thread immediately. The order doesn't matter. Here we just want to create a server socket, listening to all the incoming connections, incoming requests from the customers. So for that, I create a server. Let's name it server. Yes, server. and I create server socket.
You're making two threads and they will do each function separately.
Yes, this thread will start from this line and will
In the main menu.
end here. But this thread won't end because we have a while loop. Maybe we have some exceptions in the middle of the way, then it will end. But if we don't have an exception here, it will loop forever until
you want to do two things
simultaneously.
Synchronous.
Yes.
Spots.
No, not
Is that
synchronous.
not good word?
Not synchronously. We don't want to sync them. They are not in
I
sync.
mean that synchronously they do together.
No,
Parallel.
that's parallel, simultaneously.
Parallel is better.
Yes. That's the
And
reason I told you that the order doesn't matter here. Maybe I start the second thread first. I can switch the place.
And they can talk together.
Yes.
During the way.
They can,
know
of course.
What will happen,
Of course.
for example.
They
And
can
modify each other.
because they share the same process, because they are inside the same process, inside the same application, and they are accessing the same code. Also, they are sharing the same data. For example, both of them can access and change the shop name.
I mean that when something changed in the one thread, does it affect the other one?
Yes. That, they say that's the reason that say
exactly at that time.
Yes. That's the reason why they say that the threads are very dangerous, because
because
one thread is changing something while the other thread depends on that. And
while one causes an error, we don't know which one causes an error.
Yes. For example, one of them is changing the shop name for some reason. The other thread has checked that, okay, this shop name is not empty, so I'm going to do this. But meanwhile, this other thread comes and changes that value, because they are running synchronously, simultaneously,
but the
not
previous
synchronous.
one thought that there's nothing.
Yes. For example, like something like that. A lot of things may happen when we have more than one thread. And we will have a lot of issues when we have threads. Applications with multi-threads tend to have a lot of issues. Yeah. But we don't have any choice here, because there must be other thread here just for listening for incoming connections, just for that purpose. No other choice here. So this server socket will be listening on this machine. This machine has got some IP address in the network that is connected to. For example, it is connecting to the router or a Wi-Fi router or something like that, with cable or Wi-Fi or something like that. And it has got an IP address. It also may be connected to the internet and has an IP address inside the whole network. So that address, for example, I want to tell you that this server here cannot tell that I am listening on this address on this port also, because this machine already has an address. It cannot specify the address. We are just going to specify the port that we are going to listen. The sender, of course, the client, not only should specify the port number, but also should specify the IP address of the server, the IP address of the machine.
They should have the same port, and
the same port is
and the sender should have the IP address.
IP address of the server.
Of the
server.
Of the target.
Yes, because the client should know.
Machine.
It is the equivalent of just calling the using the phone for calling. The admin, prior to this application, was sitting there and couldn't, for example, specify the address. But for example, the admin had specified that, okay, all the customers will call on, for example, the inner line of, for example, I don't know, when they press 5 after calling this number, the customer order service will pick up the phone when they press 5 after calling here. But the customer at the home, far away, not only should know the phone number, the address, because they are far from each other. But also, after calling the phone, the customer also should press 5, should know the port, to connect to some inner section inside the admin, inside the shop, for just the purpose of placing an order. That's the equivalent, that's an analogy you can think of. So let's just give the port 1, 2, 3, 4, 5, just for the moment. And after this line, the server can accept an incoming
whatever
connection. Yes, incoming connection.
That he opens the door.
Yes, opens the door, waiting there.
Waiting for for something that has 1, 2, 3, 4, 5.
It is like that the admin sitting in front of the phone, waiting for the phone to ring. And it just waits there. It does nothing else. It's just waiting, sitting there, waiting there for the phone to ring. So this accept, if you read this documentation here, it says that it's a blocking. So this thread will block here until someone connects to this machine on this port. And after it is connected, this accept will return a socket. So the server socket accepts an incoming connection, wraps it into a socket, and returns it. After that, we have this client socket. So if we reach this line, it means that the client socket is here. We have it. The client has connected to it. After this line, it means that the client has, for example, called the shop. The shop manager has picked the phone. The connection has been made, and now they can talk to each other. So for talking to the other side, the server can not only listen to the incoming voice, but can also speak. So this is bidirectional, not unidirectional. It's bidirectional connection. Can listen and can talk as well. So this client socket has a lot of stuff with it. You can, for example, see the address, the phone number of the client that is calling, or a lot of other stuffs. The thing that we are interested for the moment is the input stream and the output stream. So this stream topic, this stream is being used everywhere in all of the programming languages when you are going to connect to, for example, some file and read the content of the file, or write content to files, or when you want to connect to network, connect to socket, send something, receive something, or other places as well. You see this input stream, output stream thing everywhere. And input stream and output stream is, of course, an interface. Maybe we have not talked about the interface yet. It has some functions for sending and writing and reading data. But the data are in byte array, bytes, not strings, not numbers, not integers. If we want to send some string, first we have to serialize it to bytes, sequence of bytes, and then send it. It's like our phone. When we talk to it, when we speak to our phone, it is our voice is being converted to some kind of waves that are being sent over the phone. Then they are converted to 0, 1, 1 zeros, and then they are sent to the other side. And then the other side receives this sequence and demodules and reverse the conversion and gets back it as a voice. So they are not actually sending their voice, they are not sending. When we are sending a string, we cannot send a string. We have to serialize that. That's our other issue when we are working with streams. So we have input stream for, let's name it this, client incoming line, for example, stream, or client sending line equals client socket dot get output stream. I just store
reading and writing.
Yeah, I'm just storing them into some into some values just to use them. I don't want to call the functions of the socket over and over. I'm just holding them into some handy variables, values here. So after that here, now we have the incoming stream and the outgoing stream. We can send and receive data. But until this connection has not been disconnected by either side, by one of the sides, both parties can send and receive data. So for receiving, our ear, when we are talking to the phone, our ear is some kind of a standalone thread. It is working for itself, on itself. It is listening. It is doing its job. It's some kind of a thread. And simultaneously, I'm thinking and speaking. So my speaking and listening are two separate simultaneous
Mhm.
tasks, threads. They are doing their jobs simultaneously, without interfering. So again here, for listening for the incoming data, we have listened for the incoming connection. After the connection, for listening for the incoming data, incoming voice, again, we have to create a new thread.
Oh.
Just for that, just for this customer. So I again create a new thread and client dot incoming line dot, we have bunch of functions on the stream. All of them are for reading. You don't see any functions here for writing. Read, variations of the read. And this one is for reading from the stream byte by byte, just one by one. This is for reading and a bunch of them, byte array. We give an array and we tell the stream first fill in this stream, this array, and then get it back to me. But just for the simplicity, just let's use this read, this simplest read form that will read a single byte coming from the other side. This read, if you just read the documentation, it says that it will give you an integer. It is giving you an integer. And if this integer is -1, it means that the connection has been disconnected, disconnected, and the streams has been closed. When the connection is disconnected and the streams get closed, then if you ask the stream for incoming data, it will just tell you -1. Just to indicate that this connection has been. So I, again, put a while true here. I just put this line inside it. What happened? And every time I read a byte, I store it here. And first I check if this byte is not -1. And if it is -1, I just break, sorry, semicolon is not necessary. Break from this while loop. So we can, maybe we are going too fast. We can break from the loop. This loop will loop forever. It's while true. So because it's while true, it will loop. Yes. We are just breaking from this while. And if this is not the case, if the byte is not -1, then it means that we have the data. So let's just for the moment just print it. Not print ln. I'm just going to print it. But this byte is an number here. Let's also convert it to character. Okay. I'm not using this sending line, and at this moment, maybe this creating another thread inside this thread seems too much here, because we are just only using this while loop for printing, just listening. But if we start talking simultaneously while we are listening, you'll see that we need this thread. Now let's go and just for this session, just connect this customer to the server. So the customer will customer socket equals, this customer has to create a socket, not server socket. The customer is not going to listen for incoming connections. Customer wants to pick up the phone and connect. So it just creates a socket, and there are a lot of, we've not talked about the, we are going too fast, of course. We've not talked about the constructors and overloaded constructors, and we've just seen classes as the data transfer objects. We've not written any constructors yet, but just, bear with us, just come with us, and I'll explain it to you later. We'll be writing a lot of classes. So first, I have to give the address, the phone number of the server. So the phone number of the server here at the moment, because we are in the same machine, we have to either use the IP address of this machine. So IP address of this machine is, let me show you, is 192.168.1.7. I can use this IP address Let me copy it. I can also use the IP address of this machine in the internet, that global address. That will also work. And also I can use the loopback address. There's specific, special address loopback, which they say that is like the things that you say will go outside of the Windows and then will come back to your machine, not Windows, sorry, to your operating system. Your operating system will just will just look for the processes inside the same machine. So I'm using this address as the phone number, and the port was 1, 2, 3, 4, 5. Yes.
Mm-hmm.
So after this line, if there is some kind of a machine at this address that has some kind of process that is listening on this port, this will connect, and here we will have the socket. But if that's not the case, it will crash. We will have some kind of exception.
We can use other overloads.
No. Maybe the admin is not listening.
We use the host because we want to send or listen. Send.
We want to send.
The previous one in the admin, we use just port.
Yes, here.
Because just we want to
listen. We are physically in some kind of a place that has got some address. We cannot change it. We cannot change that address. We are physically in that place. We've got the address of the machine.
So customer use that host.
Yes.
Because to connect to exactly that device.
Yes.
That he wants to communicate.
Yes.
And okay.
You cannot actually change your phone number. It has been given to you by the authorities. Yes. You can when you are sitting there waiting for a call, you cannot change your phone number. But maybe you can, for example, configure your phone for some kind of I don't know what they call.
Okay.
Yes. But the caller, of course, has to know
the
number of your number to call you. So it knows, the customer knows the number and the port. It will connect again after this line, because this is a socket. Just take a look. This is a socket.
Okay, I've got it.
And the fun part here is that after the server accepts, it returns a socket.
Right.
It is like it is returning that socket that was on the other part. So the socket had the input stream, had the output stream. So
that's like in the address, for example, we can like postman, yes?
Yes.
The host is the address and the port is the ring.
Yes. The port is of course the floor, for example.
For example, I'm the postman. Which address go there? Which floor?
Yes.
Port 1, 2, 3, 4, 5.
Yes. All the floors in the same buildings has got the same address.
Yes. Okay. Yeah.
Customer in is customer socket dot get input stream, and customer
get
out. Yes.
Get for receiving.
Yes.
But now here we should use output.
We will use both of them here.
No, exactly. Now I mean that we want to.
The customer wants to send something.
So send
should use the output stream.
Output stream.
Yes. But the server for receiving should listen on the input stream. They are just connected to each other. We have an input stream, output stream on this side. The other side is the vice versa.
Two-side communication.
Yes, bi-directional communication.
Bi-directional.
Yes. So we have this customer in. Let's just for the moment send something to the other side. For example, to the customer, for sending, we should use customer out. And we have writes, of course, not reads. We have reads in the customer in.
Here, writes customer.
Yes. For sending information, for example, we have to send bytes. We cannot send strings. We have to first convert our voice. And that's the job of this telephone, this machine, our mobile. That's the job of that converts our voice, converts the string to sequence of bytes, for example. But here we have to do it manually. For example, I'm sending number 60 as byte, or I'm sending 61, 62, 63. Yes?
That would be a character.
That is a character in the ASCII charset or the UTF-8, and we will talk about them later, of course. But the other side is interpreting the receiving numbers as characters. So, for example, for receiving number 60, it will see that, okay, this is the A, for example, uppercase, lowercase A, or let's see, of course.
That can be somehow coding and decoding.
Yes, coding and decoding, of course.
Crypto.
That is no, not encryption and decryption. Encryption and decryption is something else. So you can see that, okay, nothing is visible here because we are not printing. But I show you that this thread is being stopped, waiting here. Now, if I run this part, it just executed without any exception, without any error. Now, if we come to this part, sorry, to here, admin, you can see that that we have
61,
yes,
62
60
is
these characters.
this, yeah.
You can see that the admin is working. Let me, for example, enter 5 for or 6. Yes, not implemented, and the application exited because an exception, but it was working. So we had 2 threads there, just 2 threads running simultaneously. Again, let's send, for example, 90. 90 is, I think, A, B, C, D, I think. I've forgotten. Let me run this part to connect to the other side. And Z and these characters, yes.
Interesting.
Yes. And also, for example, let's change the shop name here, 0. Please enter shop name, for example, my shop. It is working. The other thread is working as well. Just look at here. I just no, I cannot do this anymore because I've not put the incoming waiting for incoming connection in a loop. At this side, I'm just only waiting for a single connection, and after that, this thread will end. I can put this whole thread into a loop, into a while true loop, and then I will be listening to incoming connections over and over and over. Okay, I know this is a lot for you. We are creating instances of classes. We are using their constructors. We are calling functions on these objects or data transfer objects, DTOs. We are using the sockets. The socket is a huge topic for itself, for the beginners on itself. And the streams, input stream, output stream, apart from the socket programming, it has a lot of nuances, on its own. But these are the things, that's stuff that we will be tinkering with, we will be working with, and if you follow, you'll get fluent with these things. I just promise that. Just don't get disappointed at this point. I know that it is looking a lot.
It's interesting.
But it's interesting. It's fun. Yes.
For the people who love
It's
programming.
Yes. I just, for example, I assume that after, for example, 20 sessions from now, when we see 2 graphical applications that are connecting to each other, the customer is signing up, logging in, seeing the products from the far away, placing order. The admin is working with this application in a graphical user interface. You'll be interested. You'll be watching these sessions. You'll be studying about the sockets on your own, and you'll get fluent on these things. Okay, I think this is enough, yes, for this session. We'll continue from here on.
Thanks for watching.
Thanks for watching.
Support.
Yes.
Goodbye.
Bye.